All right, hello everybody. It is time to start going through the topic for review. This is another one, like I've mentioned about some of my reviews so far, where I don't have an answer key for it. So bear with me if I make mistakes while I'm solving, because I don't have anything to look at to confirm. This is just coming straight from my brain as it gets here. So first of all, for exercises 6 and 7, determine if figure A and figure B are congruent. If so, describe a sequence of rigid motions that maps figure A onto figure B, and if not, explain. So of course in number 6, we can find out that they are congruent by a reflection over a vertical line. However, in number 7, those are not congruent because they're different sizes. Not congruent because they are different sizes. Number 8, if a figure is reflected across the same line twice, is the resulting image congruent to that figure, and explain. So if we take a shape A, right? Maybe we'll use this triangle right here, and we reflect it across the line, so it becomes this triangle right here, and then we reflect it across the line again, it's going to become this triangle right here. And the question is the resulting image congruent to the original figure? Yes, it will be, because the resulting image is the original figure. So yes, because the resulting image is the original figure. Also, because we're just doing a series of rigid motions, and we know that when we complete a series of rigid motions, the new shape is going to be congruent to the old shape. So this is just some rigid motions and maybe kind of a unique scenario, but it definitely will be congruent because all we did was do reflections. Number 9, find the unknown measures for each triangle. Well, this is an isosceles triangle. We know one of the measures is 45, so we know that the other base angle will also be 45 degrees. So we can do 180 minus 45 minus 45. That gives us 90. So we know that angle G is 90 degrees, and that's all the angle measures for that triangle. Number 10, we have a similar thing. We have an isosceles triangle with a measure of 40. But that means that L and M have to be congruent to one another, since the side length LN and LM are the same. So we can do 180 minus 40, which gives us 140 degrees. Divide that by 2 to find out that each of the base angles is 70 degrees. Down here, ignore the numbering. I just grabbed these questions from different places. Use the diagram to find the missing angle measures. So we've got a kind of a crazy diagram here. I see an equilateral triangle here. I see an isosceles triangle here. And I see a right triangle that is also isosceles over here. So the first one is angle PTO, which is this angle right here, PTQ rather, this angle right here. So what I know about this one is that it is part of an isosceles triangle. So that means this angle and angle Q are the same measure. So I can do 180 minus 90 gives me 90 degrees to split between Q and T, split them equally. That gives me 45 degrees for PTQ. So 45 there, because I knew that this one was also 45 up here. The next one is QTR, which is the little bitty angle right here, QTR. And when I'm thinking about this one, I have to think, well, what is this entire angle? Here, I have an isosceles triangle with a vertex angle of 60 degrees, which means this angle, P, and this angle, T, the entire thing, must have the same measure. So if I do 180 minus 60, I get 120. Divide that in half, I get 60 and 60. So PRT is also an equilateral triangle. If angle RTP is 60, I can do 60 minus 45 and get 15 degrees for angle QTR. And then finally, angle PTS. Angle PTS is the entire thing right here. I know that RTS must be 60 degrees because triangle RTS is equilateral. So I have 60 plus 15 plus 45. That's 60 plus 60, which is 120 degrees. Number 11, a zipper bisects the vertex of the front of the tent, which is in the shape of an equilateral triangle, forming two triangles. What are the angle measures of the resulting triangles? So if this is an equilateral triangle, it originally had side lengths of 60, 60, and 60 up top, but since we've bisected that 60 up top, we get 30 and 30. And then since we're using a bisector of a triangle which is isosceles, since it's equilateral, it's also isosceles, then this bisector becomes the perpendicular bisector of the opposite side, which means that these angles down here are 90 degrees because that is perpendicular. So two triangles with measures of 30, 60, and 90 degrees. That's going to become a lot more important later on this year. So down to triangle congruence. Which pair of triangles are congruent by side, angle, side, or side, side, side? Well, in this diagram, we've got an angle pair, a second angle pair, and then DB. So I know that AB is congruent to CD, and I know that AD is congruent to BC. Those two are given. And I know that DB is congruent to DB by the reflexive property, because everything is congruent to itself, which then means my triangles are congruent by side, side, side. So triangle ABD is congruent to triangle, what would that one be called? CDB. CDB by side, side, side congruence. Number 13, it looks like I have a pair of congruent sides. So GF is congruent to GH. I have a pair of congruent angles. Angle F is congruent to angle H. And I have a pair of congruent sides, that is the reflexive property. So these two are given. And then that reflexive property tells me that GJ is congruent to GJ, or JG, whichever, it doesn't matter. And that's all I can find. I don't know anything else about the angles or the sides or the congruencies within those angles and sides. So now, I can't say that those two triangles are congruent. I have an angle, side, so angle, side, side pattern here. An angle, side, side is not one of my congruency postulates. So having angle, side, side right here does not mean anything about whether or not I am able to create congruent triangles right here. So this is going to be not congruent. We don't know that it's congruent, so it's not congruent. Here we've got some overlapping triangles, and we are asking about certain ones of them. So number 5, it says, is triangle WVS congruent to WVU? So if I see WVS here, and I see WVU here, I see that they both have a right angle. They both have a third side, or a second side, that is congruent here in the middle because they share it. So that means they are congruent by side, angle, side. So yes, by side, angle, side. Then we've got the next one, is triangle TVS right here congruent to triangle TVU? Let's see what we've got here. So that one seems like we've got the same idea. We've got this side in the middle that's the same as itself. And we know that SV and VU are congruent. And we also know that we have a right angle right here. So they are, yes, they are congruent by side, angle, side. And finally, is triangle TWS congruent to triangle TWU? So TWS right here. and TWU. What have we got here? We have, depending on how we look at this, whether we're using 5 and 6 in before, if we're using 5 and 6 beforehand, then yes, of course, these two triangles would be congruent because we could say that their side lengths were congruent, and then we could use side, side, side. But if we were not using the information from 5 and 6, which is what we want to do here, we don't want to use the information from 5 and 6, then I see a shared side, TW, that is congruent to itself. But I don't see a way to find any other angle congruencies at the moment, or side congruencies, because I don't have any information that could lead me to say that side TU is congruent to side TS. There's no angles that could tell me that. I don't have anything that would say that WS is congruent to WU. There's no angles or anything that would say that. So at this point, I have to say that I don't think that there's enough information to show that these are congruent. So we can say not enough information. Okay? But of course, now that I'm looking at this, we can. Because no matter what, we can say that certain pieces and parts are congruent based on 5 and 6. Because even if I'm looking at this diagram and starting fresh, I can say that TS is congruent to TU by CPCTC from the triangles in number 6. I know that because I could figure that out even without number 6 being on here. And I know that SV is congruent to, SW is congruent to WU by CPCTC from number 5. Because again, even if I didn't have number 5 on this paper, I could say that those two triangles were congruent based on the information. So I could say that SV and WU definitely had to be congruent. And that means that yes, triangle TWS is congruent to triangle TWU by side, side, side. All right, let's keep going here. Number 15 and 16 state whether each pair of triangles is congruent by side, angle, side, 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 angle, or angle, angle, side. Or the congruence cannot be determined. So these two triangles, they don't have labels on them, so we don't need to write congruency statements, but we can see that they share this side in the middle, so they're congruent by side, side, side. In number 16, I have an angle with 2 arcs, an angle with 1 arc, and then a side length. I have an angle with 2 arcs, an angle with 1 arc, and then a side length. So these are congruent by angle, angle, side. It is really important to note which angles are here. If this went 1 arc, 2 arcs, side length, they would not be congruent. But here it goes 2 arcs, 1 arc, side length, 2 arcs, 1 arc, side length. So they are congruent by angle, angle, side. Generalized are 2 triangles with 2 pairs of congruent angles and 1 pair of congruent sides, always congruent. Make a generalization. Let's draw some triangles. So here is a pair of 2 triangles, and we are saying, what are we saying here? That 2 of their angles are congruent. So maybe the top angles and the left angles are congruent. And 1 pair of their sides. So 1 pair of their sides could be the sides in between the congruent angles for angle, side, angle. But also, there is the possibility that we draw these same 2 triangles, and the congruencies that we have are the angles outside, or are the sides outside of the congruent angles. So those angles are the same, but a side outside of those congruent angles is congruent. That would be angle, angle, side congruence. So we can say yes, because they will be congruent either by angle, side, angle, or angle, angle, side. Number 18, are these triangles congruent? Explain by which congruence criterion. So I'm looking at the order these are going, and I see that there's one arc, and then two arcs, and then the side length right next to it. Here I see two arcs, and then one arc, and then the side length right next to it. These are not congruent. Because those angles that are lined up are not corresponding. The one arc angle corresponds with the two arc angle, and that doesn't work. So the angles are not corresponding. And I'm going to add a word in here. I'm going to say that the congruent angles are not corresponding, because there is a pair of congruent angles, but they're not in the same position relative to the congruent side. This angle is opposite of the congruent side, and this angle is next to the congruent side. So those triangles would not be congruent. Oops. 4-5, prove that each pair of triangles is congruent. So here is a pair of triangles, and I don't have any actual letters here, so I don't really think I can compare based on the letters. But I do know that this middle segment is going to be congruent to itself. So that piece that's kind of half of each of those triangles is congruent to itself, which means that this entire side, I'm going to make it red, and this entire side, I'm going to make it blue, are congruent by the by the segment addition postulate, where I'm taking this big segment and this little segment that I know are 1 hash mark and 3 hash marks, and this big segment and this little segment that I know are 1 hash mark and 3 hash marks. And I'm saying, well, those must be the same. So the triangles, which are two right triangles, are congruent by hypotenuse leg congruence due to, I'm going to write two things, due to the reflexive property, which shows that that overlap area is congruent to itself, and the segment addition postulate. So that's not really a proof, but it is important. All right, number 20, triangle ABC is an isosceles triangle with a vertex bisected by a line segment. Draw the triangle and prove that the resulting triangles are congruent. So we'll draw ourselves an isosceles triangle here. And we'll say, all right, this is isosceles, will be A, B, C. And it says that the vertex is bisected by a line segment. So here are congruent sides. The vertex is bisected, just like that. So that's our information that we are starting with. Let's go ahead and make our proof with our statements and our reasons. So I know, number one, that, I'm going to put a D down there to give ourselves another point. I know that I know that the triangle is isosceles, so I know AC is congruent to AB, that's given. And I know that the vertex is bisected by a line segment, so I know that angle CAD is congruent to angle BAD. That's given. So both of those are given. I know that AD is congruent to itself. So is that going to help me? You know, there are ways that it could help me. I'll use that. AD, not angle AD. AD is congruent to AD by the reflexive property. Step 3 then, once I find that out, is I I had an angle bisector theorem at the beginning of this chapter that says if the vertex angle is bisected, then that makes the resulting line the perpendicular bisector of the triangle. So I know that AD is perpendicular to CB, and I know that because of the triangle angle bisector theorem. All right, number 4 then, I'm going to say that angle CDA is congruent to angle BDA, because those angles must be the same based on the definition of congruent, the definition of perpendicular. All perpendicular angles are 90-degree angles. So the definition of perpendicular. And now I know that these triangles are congruent. Triangle ACD is congruent to triangle ABD by angle side angle, because I've got this top angle, this side, and this bottom angle. However, I could have proven this completely differently by using the isosceles triangle theorem. I know it's an isosceles triangle, to show that angle B and angle C are congruent, and then used angle side angle with this bisected angle. The side that was given to me is congruent, and the base angle. That might have even been a shorter proof, but I wanted to show you this one instead. All right. Then we've got 2 more. We've got to prove that each pair of triangles are congruent. Again, here we have no letters, so I am going to kind of walk you through this instead. I know that they have congruent right angles. So I know that they are right triangles. I know they have congruent top angles. Congruent top angles. Those are all given. And I know that their hypotenuses are both 3x. Hypotenuses, both 3x, because of the segment addition postulate. X plus x plus x is 3x. So because of segment addition postulate. Therefore, these triangles are congruent triangles by angle side. I'm sorry. Yeah. Angle side congruence. So that's what we have here. Angle side. Number 22. Here we do have some letters. We don't have all the letters. We want to show that which triangles are congruent. It says prove that each pair of triangles are congruent, but it doesn't tell us which pair. That's interesting. So I could go a bunch of different ways with this one. Which one do I want to show as being congruent? I think I'm going to show, and I'll highlight these for you. I'm going to show that triangle ACB or ABC is congruent to triangle FED. And I'm going to do that in sort of a roundabout way. So the first thing I've got to do is make my proof, statements and reasons. So we've got statements, and we've got reasons. So let's see, I've got information that's given to me. I'm going to say that I'm going to start by proving that these small triangles are congruent to one another. So I'm going to say that ED is congruent to BC, and angle D is congruent to angle C, and that is given. For step 2, I'm going to say that angle EGD is congruent to angle BGC by vertical angles. So I know that those two angles are congruent to one another, which means that I know those triangles, triangle EGD is congruent to triangle BGC. They're congruent by angle, angle, side. Once I know that those triangles are congruent, then I can state that a couple of pieces and parts that I'm going to need are congruent. I can state that EG is congruent to BG, and I can also state that DG is congruent to GC, both of those because of CPCTC. I know those pieces and parts of the triangles are congruent. So I can put, this diagram's going to get messy, but there's 3 hash marks here, 4 hash marks here. And knowing that, I now know, number 5, I now know that another piece was congruent. I know that AE was congruent to FB. That was given. That was there when I started this problem. So knowing that, I have AC. That is a 1 hash mark plus a 4 hash mark plus a 3 hash mark. And I know FD. That is a 1 hash mark plus a 4 hash mark plus a 3 hash mark. So I can say that AC is congruent to FD by the by the segment addition postulate. I have 3 segments actually that are congruent to 3 other segments, and if I add those 3 segments together, they will be congruent to those 3 other segments added together. So finally, if I look at triangle EDF, I have side, angle, side congruence. So triangle EDF is congruent to triangle BCA by side, angle, side. Now I'm sure that there are other ways to do that problem, but I wanted to show you that one just so that there is an example here that you can kind of see where we make 2 congruent triangles and then use those to find the angles or the sides that we need in other congruent triangles. And then finally, list the corresponding sides and angles in the pair of triangles, triangle GHJ, and triangle JKG, just like this. There we go. So the corresponding sides would be GH is corresponding, I'm just going to use a little squiggly there, to G8, or to JK, I'm sorry. Also GJ or JG is corresponding to itself, and GK is corresponding to JH. With angles, I can say angle JGH is corresponding to angle GJK, and angle GHJ is corresponding to angle GHJ, JKG. And finally, which angle have I not covered yet? I have JGH. Nope, I have that one. GJH is what I need to cover. Angle GJH is corresponding to angle JGK. So what that means is that if I prove that these two triangles are congruent through whatever means necessary and whatever information that I'm given, all of these congruencies will be true. So GH would be congruent to JK, JG would be congruent to itself, GK would be congruent to JH, and so on and so forth. All right, and I think that that is everything for this. Kind of a longer one with the proofs, but they're good practice.